Implement BTP VLAN trunking protocol. This topology D1, D2, A1. I will use image iOS VL2, 3 devices, change the host name D1, D2, A1, and connect them gigabit 101, 5612, 5634. Okay, between D1 and D2. I will use a similar interface gigabit 01. And instead of use 5 and 6, I will use 11 and 12. 11 to gigabit 01, 12 to gigabit 02, 11 to gigabit 03, and 12 to gigabit 10. Okay. VLAN trunking protocol BTP is a technology that manages the addition, deletion, and remaining of VLANs of the entire network from a single switch. Although not commonly used in modern networks that support programmability, BTP can be a useful tool as long as it is carefully managed. A BTP domain, also called VLAN management domain, consists of trunked switches that are under the same administrative control sharing the same BTP domain name. A switch can be in only one BTP domain, and VLAN database contents in the domain are globally synchronized. VLAN information is not propagated until a domain name is specified and trunks are set up between the devices. There are 3 versions of BTP available. 1 is the default. By default, versions 1 and 2 can support only normal range of VLANs. Version 3 can support normal and extended range VLANs, as well as the synchronization of other databases like MST. Support for BTP version 3 only on the Catalyst platform was added in iOS version 12.2. Older iOS versions do not generally support BTP version 3. Switches operate in one of 4 BTP modes. The default BTP mode is server mode. BTP server. You can create, modify, and delete VLANs as well as specify other configurations parameters such as BTP version and BTP pruning for the entire BTP domain. BTP servers advertise their VLANs configuration to other switches in the same BTP domain and synchronize their VLAN configuration with other switches based on advertisements received over trunk links. BTP server is the default mode. In BTP server mode, VLAN configurations are only stored in the VLAN.dat file, while VLANs are manipulated in the configuration mode. The configuration commands do not appear in the running configuration. Btp Client. A Btp client behaves like a BTP server and transmits and receives BTP updates on its trunks, but you cannot create, change, or delete VLANs on a Btp client. VLANs are configured on another switch in the domain that is in server mode. In Btp client mode, learned VLANs are only stored in the VLAN.dat file. The configuration of VLANs does not appear in the running configuration. Btp transparent. Btp transparent switches do not participate in BTP. A Btp transparent switch does not advertise nor synchronize its VLAN database based on received advertisements. However, Transparent switches will forward receive BTP messages under two circumstances. Either the BTP domain name of the transparent switch is empty, not yet configured, or it matches the domain name in the received BTP messages. In BTP transparent mode, normal range VLANs configurations are stored both in VLAN.dat file and they are also present in the running configuration. If extended range VLANs are used, they are stored in the VLAN.dat only if the switch is running BTP version 3. In version 1 or 2, extended VLANs are stored in the running configuration. BTP off. A switch in BTP off mode functions in the same manner as BTP transparent switch, except that it does not forward BTP advertisements on trunks. BTP off is only available on switches that support BTP version 3. Although it is not necessary to run BTP version 3 on the switch to be able to put into BTP off mode. In BTP off mode, normal range VLANs configurations are stored both in flash.dat file and are also present in the running configuration. Similar to transparent mode, when using BTP version 3, both normal and extended range VLANs are stored in VLAN.dat file. In this lab, you will set up and observe the operation of BTP version 2 and BTP version 3. This lab is an exercise in deploying and verifying BTP and does not reflect networking best practices. Ensure that the switches have been erased and have no startup configurations. Required resources on real lab 2 switches 3650. I'm using iOS BL2 image. One switch Cisco 2960. In this case, I'm using also iOS BL2. Console cables, Ethernet cables. Build the network, configure basic device settings and interface addressing. Configure basic settings for each switch. Okay, the basic settings for D1, D2, and A1. Copy this to Notepad. Okay, and review. Switch D1, hostname, banner, spanning tree, line console. Shut down all interfaces, but in my case the range is different. Use this range from gigabit 00 to 03, from 10 to 13, from 20 to 23, from 30 to 33. Okay, gigabit from gigabit 00 to 03, gigabit 10 to 13, gigabit 20 to 23, and gigabit 30 to 33. Okay, shut down all the range of interfaces and configure the trunks 3 interfaces, the trunks gigabit 0102 and gigabit 11, gigabit 0102 and gigabit 11. Okay, and switch port trunk encapsulation.1q. In this layer 3 switches, be sure the encapsulation is configured before to configure the mode trunk. Okay, and on these 3 interfaces. Okay, and enable those trunks. Now switch to hostname banner, shut down all interfaces. So use the same ports to shut down and enable the range of interfaces. They are the same ports, in my case 01, 11 and 12. Okay, it is gigabit 01 and gigabit 11 and 12. Okay, be careful, gigabit 01 and gigabit 11 and 12. Gigabit 01, comma, gigabit 11 and 12. Okay, and switch. Okay, switch D2. Enter hostname banner spelling tree line console. Shut down all interfaces. Use the same range because it's the same image. And enable three trunks. These trunks, and they are the same as D1, 01, 11, and 12. So copy this 01, 11, and also the encapsulation. 01, 11, 12 encapsulation mode trunks and shutdown. And for switch A1, enter hostname banner and then console. Shut down all interfaces. Okay, all interfaces on A1 is the same image, so copy this range. And switch port mode trunk on 4 interfaces. In my case, from gigabit 01, 02, 03, and 10. Okay, from gigabit 01, 02, 03, and gigabit 10. Okay, 4 interfaces. And don't forget the encapsulation, switch port trunk encapsulation.1q. Okay, very nice. Switch port trunk encapsulation.1q. And start the devices, start D1, D2, and start A1. Okay, D1, D2, A1. Okay, and start with D1. Okay, enter. This is D1, and copy the basic configuration. Copy, enable, configure terminal. Once you are on global configuration mode, okay, enter and right click to paste. Okay, verify hostname banner line console, the range of interfaces, the range of trunks. Very good. D2, enter, enable, configure terminal. Copy this and right click to paste. And A1, enter, enable, configure terminal. copy, right click, okay. Implement and observe a BTP version 2 domain. Verify BTP status. On D1, issue command show BTP status. Okay. D1 and show BTP status. Now, by default, the version is 1, the running version. But this switch is capable to run from 1 to 3 versions. Okay, BTP domain name empty by default. Btp operation mode by default server. Configuration revision 0. Because no VLAN configurations were made, all settings are the defaults. This switch is capable of running versions 1, 2, or 3 of BTP and runs version 1 by default. All switches in the BTP domain must run the same BTP version. The number of existing VLANs is the 5 built-in VLANs. Okay, number of existing VLANs 5. Okay, show VLAN brief. The 5 VLANs. Okay, and different switches in the Catalyst family support different numbers of local VLANs. Lastly, note that the configuration revision is 0. Okay, 0 means no configurations, no modifications. Multiple switches in the BTP domain can be in BTP server mode. In BTP 1 and BTP 2, any of these server switches can be used to centrally manage VLANs for all other switches in the BTP domain. The configuration revision number is compared amongst BTP version 1 or BTP version 2 switches. The VLAN database from the switch with the highest revision number is adopted by all the other switches in the VLAN management domain. Every time VLAN configuration is modified and saved in the VLAN database, VLAN.dat, the revision number is increased by 1 when the user exits from VLAN configuration mode. BTP messages only pass over trunks between switches. They are not sent out of access ports. Now, configure and observe BTP version 2 domain operations. Configure D1 to operate in BTP server mode and set BTP domain name and BTP version 2. We will also set BTP password, which provides some rudimentary protection against automatic VLAN database propagation. Because this password is set, BTP version 2 will not allow other switches to automatically learn the domain name. Okay, and configure all this on D1. Configure terminal, BTP domain, CCNP version 8. Okay, enter. Okay, BTP version 2, BTP mode server, already BTP server, and BTP password Cisco 123, and exit. On D1, create VLAN 2 and name it second VLAN. Assign port 23 to VLAN. Assign port 23 to that VLAN and verify the BTP status again. Notice the revision number has incremented. Also verify the port assigned to the VLAN. Okay, these configurations configure terminal VLAN 2, name second VLAN, exit, interface. I will use gigabit 23. It's an existing port on D1. 23. It's not in use, but anyway, configure this port. And switch port mode access. And switch port access VLAN 2. And no shutdown. Enter. And okay, and verify the port with show VLAN brief and the revision number show BTP status. Okay, show VLAN brief. Okay, interface 23 is assigned to VLAN 2 and show BTP status. The revision is 2. Configuration revision is 2. Okay, and now the existing VLANs are 6. And now the BTP version running is 2. The domain name CCNP version 8. The Btp mode server, very good. And also you can view the password, show Btp password, and you can see the password. So that's why it says it's rudimentary, because you can see the password. It's not secure. Okay, and on the one create VLAN 2048. If you are working this lab on something other than iOS XE based switch, you will not allow it to create VLAN 2048 in BTP version 1 or 2 in server mode. Okay, I will try this in this image. Configure terminal, VLAN 2048. Very good, and exit. Okay, remember all this on D1. On D1. And verify, show VLAN brief. Okay, this VLAN at the end. Now show BTP status. Before to create VLAN 2048, number of existing VLAN 6, and after create the VLAN 2048, number of existing VLANs 6. So for BTP, VLAN 2048 is not included. Verify D2 and A1 have not learned about the new VLANs by examining the output of show VLAN brief. D2 and show VLAN brief. Okay, no VLANs learned, A1, and show VLAN brief. No VLANs learned. Configure D2 and A1 with the same BTP domain, version, and password as configured on D1. Okay, use the same configuration like this. Okay, but use the same BTP domain name, version, and password. That is enough. Okay, only the domain, the version, and password. Do not configure server because these devices already configured the servers. Okay, go to D2, configure terminal, BTP domain CCNP V8. BTP version 2, BTP password Cisco 123. Okay, BTP domain already set, BTP version 2 already set, but the password is missing, so you need to configure the password. Okay, go to A1, so you can verify. Look at this, show BTP status. Okay, before to configure, and now already the domain name, already in version 2, already domain name CCNP, but password is missing. Okay, BTP show password, show BTP password. Okay, no password, so that's why in A1 cannot synchronize the VLANs. Okay, show VLAN brief, no VLANs, and configure terminal. Set the version and domain anyway. BTP domain CCNP V8 case sensitive, BTP version 2, and BTP password Cisco 123. Okay, and now go to D2. Look at this. Instead of waiting for the DTP update timer to expire, shut down and enable interfaces gigabit 01 on D2 and gigabit 01 on A1 to force DTP update. Okay, to force DTP update, shut down and enable gigabit 01 in this case. Okay, the connection to D1 to force DTP update, shut down and enable gigabit 01 on A1, the connection to D1. Okay, but then verify that D2 and A1 now have the same BTP configuration revision number. Okay, go to, I think only you need to wait in D2 and show BTP status. Show BTP status. Sorry, status. Okay, domain name, version 2, very good. Only 5 VLANs. So VLANs still not synchronized. And show VLAN brief. Okay, no synchronized VLANs. You only need to wait the DTP update timer. Okay, okay, show VLAN brief, and now ready. Okay, go to show BTP status. Now you have 6 VLANs. Show VLAN brief, the 6 VLANs. The second VLAN with VLAN 2048 is not included. Okay, however, they not have the same VLAN database. D1 does not propagate information about extended VLANs, the VLAN 2048, via BTP version 2. Notice from the output show VLAN brief that the only thing learned was the VLAN number and name. The port assignment was not propagated. Port assignments to VLANs still have to be done on per switch basis. Okay, go to A1 and show BTP status. Now you have 6 VLANs, show VLAN brief. Okay, the 6 VLANs 2048 not included. Also on D2 you can view show BTP status include VLANs or revision. Show BTP status pipe include VLANs or revision. Enter. Now you can see 6 VLANs and the revision number 2. The same revision number as the server. On A1, the same revision number as the server. D1 is the server. On D2, show VLAN brief, very good. To demonstrate the main drawback to BTP, go to A1 and remove VLAN 2 with no VLAN 2 command. The command should complete successfully. Okay, go to A1 and remove configure terminal no VLAN 2 enter. Then A1 the revision number should be 3. Okay, and show BTP status pipe include revision. Okay, now the revision number is 3. And go to D1, show BTP status. The revision number now is 3. And go to D2, show BTP status. The revision number now is 3. Go to D1 and see if VLAN 2 still exists. Okay, go to D1, show VLAN brief. No VLAN number 2. D2, show VLAN brief. No VLAN number 2. You will see that it does not. This is the main drawback to BTP version 2. Without careful control, an existing switch or newly added switch with the same BTP domain, information could override the existing database because it only compares the configuration revision number instead of the client server mode. Also, note that the status of interfaces 2.3 it is not listed in the output of show VLAN brief. Okay, on D1, 2.3 is not listed in this output. Okay, before before 2.3 was assigned to the second VLAN, but now 2.3 is not listed because VLAN 2 does not exist. The interface is unusable because it is assigned to VLAN that does not exist. Remember that the VLAN database contents and the port assignment to a VLAN are two separate things, and they are not synchronized. Okay, go to D1 and no port 2.3. In this case, on the lab 23. In my case, no port gigabit 2.3. Show BTP status, and the revision number is 3. On D1, create VLAN 2 with the same second VLAN. Okay, configure terminal VLAN 2. Name second VLAN 2. Enter. Recreate VLAN 2 with the name second VLAN 2. Verify that the BTP configuration revision number increases. The VLAN appears in the database and that gigabit 2.3 is listed in the show VLAN brief output once again. Okay, and exit from VLAN configuration mode. This is necessary to apply changes and use end or exit, but show BTP status. The revision is 4. Show VLAN brief. Include gigabit to 3 in my case. Okay, is gigabit. Okay, second VLAN with this interface. Very good. On A1, change the Btp mode to client and then attempt to create VLAN 3. It will not be allowed. Btp Client mode prevents new VLANs from being created, modified, or deleted. But Btp Client with a higher revision number will still override the Btp server switch database. The typical scenario is a switch using the same Btp information, domain, and password in a test network has a higher revision number and is placed on the production network without being cleared. Okay, go to A1, configure terminal, Btp Modes, client. Okay, and try to create VLAN 3. Btp VLAN configuration not allowed when device is in client mode. Okay, and show Btp status. The revision number is 4. Okay, the same revision number as the server. Server was D1. Okay, show Btp status 4. Okay, and on D2, change the Btp mode to transparent. Then attempt to create VLAN 3 with the name third VLAN. You will succeed. Verify that it is in the output of show VLAN brief. Note the Btp configuration revision number. Okay, go to D2, configure terminal Btp mode transparent and create VLAN 3 and set the name third VLAN and now show VLAN brief. Third VLAN in the show VLAN brief output and show Btp status. Show Btp status include domain or revision. Okay, the domain is CCNP v8, but the configuration revision is 0. In transparent mode does not participate in Btp. On D2, create VLAN 1111 with the name quad1. Okay, on transparent switch, configure terminal VLAN 1111, name quad1, and show VLAN brief. Okay, now is included. Btp status, configuration revision 0. Okay, configuration revision 0. Check D1 to see if VLAN 3 or VLAN quad 1 has been learned. They will not have been. Okay, D1, show VLAN brief. Okay, no VLAN 3, neither VLAN quad 1. Btp transparent switches keep to themselves in the Btp domain. and do not learn or propagate VLAN information from other switches. On D1, shutdown interfaces gigabit 11 and 12. Okay, on D1, shutdown gigabit 11 and 12. Then create VLAN 4 with the name 4th VLAN. Verify that it is in the database and that the BTP configuration revision number has incremented. Okay, go to D1, to this device, and shut down gigabit 11 and 12, the connection to A1. Okay, so basically disconnect D1 to A1. D1, configure terminal, interface, range, gigabit 11 and 12, shut down, exit. Okay, and create VLAN 4. VLAN 4 name 4th VLAN. Exit, necessary exit, and verify show VLAN brief and show VLAN brief. Okay, 4th VLAN in the database. BTP status, show BTP status. Revision number now is 5. Before was 4, but now is 5. Check D2 and A1 to see if they have learned about the existence of VLAN 4. Okay, go to D2, show VLAN brief, no VLAN 4, show BTP status, revision, configuration revision 0, go to A1, show VLAN brief, okay, 4th VLAN in the database, show BTP status, configuration revision 5, the same configuration revision of D1, and the VLAN 4 is present on VLAN database like D1. D1 sent a BTP message to D2, which forwarded the BTP message to A1 because they shared the same BTP domain name. A1 added the VLAN to its database and increment its configuration revision number to 5. Because D2 is in transparent mode, it does not add the VLAN to its database. Okay, D2 transparent configuration revision 0, A1 configuration revision 5, A1 VLAN 4 in the database. Very nice. Now it's time to implement and observe BTP version 3 domain. You will configure BTP version 3 to operate across the rest of the switched network. BTP version 3 provides some significant benefits to the network administrator. The ability to create a primary server was added. In BTP versions 1 and 2, all BTP server switches are equal. Any of them may add, remove, or rename VLANs and change their state. In BTP version 3, only the primary server can do this. There can be only one primary server present in a BTP domain. The role of a primary server is to be a runtime state. It is not a part of the configuration. Rather, this state is requested in privileged exec mode and is relinquished whenever another switch attempts to become the primary server or when switch is reloaded. BTP version 3 has the ability to hide the Btp password. On BTP version 1 or 2, issuing the command show btp password will show the password to you in plain text. BTP version 3 allows you to specify that the password be hidden in the output, preventing the password from being inadvertently or maliciously divulged. BTP version 3 can propagate information about extended range VLANs. These are VLANs numbered between 1006 and 4084. To support these VLANs with BTP version 1 or 2, all switches have to be in transparent or off mode, and the VLANs must be configured manually on a switch-by-switch basis. Btp version 3 only supports pruning for normal range VLANs. Btp version 3 supports propagating private VLAN information. As switch extended range VLANs, the lack of private VLAN support in Btp version 2 required that all switches be in transparent mode and manually configured at each switch. Btp version 3 added support for opaque databases. In other words, Btp version 3 can transport more than just the VLAN database between switches. The only option that this time is to share the multiple spanning tree (MSTP) database, but room was left for expansion. Regardless of the BTP operation mode, a BTP domain must first be set before configuring Btp version 3. Btp version 3 is backwards compatible with Btp version 2 for normal range VLANs only. At the boundary of the two protocols, a Btp version 3 switch will send out both versions 3 and version 2 compatible messages. Version 2 messages received by a version 3 switch are discarded. Configure and verify Btp version 3 on D1. Okay, go to D1, configure terminal. And remember, the BTP domain is already set. Okay, my BTP domain is CCNP v8. So now you are able to configure Btp version 3. Enter. Okay. All version 2 VLAN configuration file detected and read OK. Version 3. And show BTP status. Space. Now, version is 3. The Btp mode is server and configuration revision is reset to 0. And the primary ID does not exist, 0. On D1, show VLAN brief. Show VLAN brief. Okay, VLAN 1, VLAN 2, VLAN 4, and VLAN 2048. On D1, try to create VLAN 6. You will not be allowed to do so. If you examine the output of show BTP status, you will see that the identification of the primary server is blank, all zeros. Okay, configure terminal. Try to create VLAN 6. BTP VLAN configuration not allowed when device is not the primary server. Okay, so you are not permitted, and exit. Show BTP status. Primary ID does not exist. On D1 issue the privilege exec command btp primary VLAN. This makes D1 the primary for the VLAN database only. There is also a primary for MST, but that is not the focus of this lab. If you issue the BTP primary command with no additional parameters, VLAN is assumed. Verify that the base MAC address for D1 is listed as the primary server ID. Okay, on user on privilege exec mode, BTP primary VLAN. Okay, this system is becoming primary server for feature VLAN. Okay, and wait a moment. No conflicting BTP3 devices found. Do you want to continue? Confirm, enter. Okay, BTP primary server changed. The base MAC address of D1 now has become the primary server for the VLAN BTP feature. Okay, and use these commands to compare. Show BTP status pipe include primary. Okay, enter. Okay, the primary ID now before was 0. Okay, 0. Before was 0, but now is the base MAC address of D1. And show hardware pipe include base. Okay, include MAC. Okay, show hardware. Okay, and no base MAC address here. You can use spanning tree. Show spanning tree. This is the base MAC address of the bridge 006479C7AA00, and it's the same like the primary ID is the same. So D1 is the primary, the primary server. Now we see that BTP version 3 is working in that it allows for extended range VLANs, while in server mode it is sending BTP version 2 compatible messages at the domain boundary, and that D2 is still passing those messages along. If you did not notice in the earlier output, verify the configuration revision number on D1 and then the number on A1. Okay, in this case, to cause a change at A1, D1 will have to have 5 revisions made to increment the revision number past what A1 currently has. Okay, on D1, verify the revision, space, show BTP status, okay, include revision, okay, is only one. The revision number is only one on my primary server for BTP version 3, but on A1 should be 5. Show BTP status is 5. Okay, and configuration revision 5. Okay, and D1, the revision is 1. Show BTP status, revision is 1. And on A1 is 5. And do the following. On D1, create following VLANs: 6, 7, 8, 9, 10, 11. Okay, go to D1, configure terminal VLAN 6, name 6 VLAN. VLAN 7, 7 VLAN, 7 VLAN, 8, 8 VLAN, 9 night VLAN, VLAN 10, 10th VLAN, 10th VLAN, VLAN 11, 11th VLAN. Then exit to save changes. And verify. And show VLAN brief. Show VLAN brief. Now you have these are the new VLANs. Okay, and the revision number is 7. Okay, previously it was 1 and 1, 2, 3, 4, 5, 6. 1 plus 6, the revision is 7. If the revision number does not increase past the number required, rename a VLAN and exit out of VLAN configuration mode to increment the revision number by 1. Okay, and now go to A1 to see if it learned the new VLANs and verify that its configuration revision number matches that of D1. We will not check D2 because it is in transparent mode. Okay, and A1, look at this BTP protocol. Okay, okay, show VLAN brief. Now you can see the new VLANs. Show BTP status. The revision number is equal than D1, 7. On D1, create VLAN 2600 with the name HackerPub. Verify that it exists in VLAN database and verify the configuration revision number. Okay, go to D1, configure terminal, VLAN 2600, extended VLAN, name HackerPub. Okay, and show BTP status and revision now is 8. Okay, show VLAN brief. Now is here HackerPub. Show BTP. See if A1 learned VLAN 2600. You will see that it did not because BTP version 2 does not support extended range VLANs. Okay, go to A1. Show BTP status. Now is 8. But show VLAN brief and no VLAN 2600. No extended VLANs because A1 is using BTP version 2. It still is using BTP version 2. Okay, and review D2. Show BTP status is version 2, but transparent mode, and show VLAN brief. No new VLANs because this is configured in transparent mode. Okay, will not participate on BTP. And configure and observe BTP version 3 domain operations. Update D2 and A1 to run BTP 3 and verify their behavior and transparent and client switches in the BTP domain. configure D2 and A1 to operate using BTP version 3. Okay, for example, on D2, set BTP version 3. Remember that on D2, the domain name is already set. So now you can configure BTP version 3. Configure terminal BTP version 3. Very nice. Okay, and on A1, go to A1. Remember the domain name already set. Configure terminal BTP version 3. Okay, look at this message. All version 2 VLAN configuration file detected and read OK. Version 3 files will be written in the future. Okay, and check the version and revision number on A1 and see that they have been updated to match D1. Verify that VLAN 2600 now exists in the VLAN database of A1. Okay, and show BTP status version 3 and revision configuration revision is 8. 13 existing VLANs. Okay, and show VLAN brief. Now you can see the extended VLANs at the end, like VLAN 2048 and Hacker Pub 2600. Very good. The same way on D2 and show VLAN brief. Okay, this is on now. Show BTP status. Now it's running BTP version 3, but is still in transparent mode. And you can see no will not participate on BTP. Check the revision number on D2 and see that it has not changed. Okay, this is D2. Okay, no revision number on BTP status, so this is in transparent mode for VLAN, for MST, for unknown. Okay, transparent mode. Show VLAN brief. No new VLANs. Okay. Thank you very much.